For our final lecture in Sociology 530 tonight, we are going to talk about multiple regression and beyond. So the last three chapters of the Allison text focus on multicollinearity, dealing with nonlinear relationships, and then other statistics that are connected to multiple regression. So multicollinearity, Allison spends an entire chapter talking about the issue of multicollinearity, which should give you a sense of just how important it is in statistics. It's also a very troublesome issue because it's hard to control for. So there are two forms of multicollinearity, what he defines as extreme multicollinearity and then near extreme multicollinearity. And when you have extreme multicollinearity, that means that at least two of the independent variables are perfectly related to each other by a linear function. And it's unusual, but it is possible for this to happen. Allison gives the example about asking people to estimate the percentages of information about current events that they get from different media sources. So if you have a question like that, and so the options might be television, radio, newspaper, and internet, adding all those percentages up should equal 100, right? So all the options together equal 100%. And that's a linear expression where x1 plus x2 plus x3 plus x4 equal 100. And so each individual variable will be 100 minus the other three. So there is a linear relationship among these variables. So you would have perfect collinearity among these variables. We talked last time and a couple of weeks ago about how dummy variables can be created to sort out this problem, to deal with it, so that you have one reference category, which would be maybe television, and then you would have radio and versus all others, newspaper versus all others, internet versus all others, leaving out the television as the reference category, and then running each individual regression. And then you can say, compared to television, this is the relationship or the coefficient for this particular media form versus television. So there are ways to deal with it by creating dummy variables, but the problem with dummy variables is it makes your model much more complicated. How do we diagnose extreme multicollinearity? In SPSS, if you do a run, you may get an error message that may note that the model is not full or that an excluded variable table is created. And what it will do is it will dump out one of those variables. If it sees extreme multicollinearity, when it does its runs, it will dump out one of those variables from the model. And so that one won't be taken into account. So it will keep one and dump the other, and you don't get to control which one gets dumped, unfortunately. But if one of them gets spat out of the model when you're running it, that's a sign that you need to look at the relationship between that variable and the other independent variables in your model. What are some of the consequences of extreme multicollinearity? Well, first of all, it's impossible to get separate estimates of each independent variable in terms of their regression coefficient. So we can't get good estimates separately, because when we try to tease out what would be sub one, what would be the coefficient for the first variable and the coefficient for a second variable, if those two are collinear, we either get an error message where one of them gets kicked out of the program, or if they're pretty closely collinear but not perfectly or not extremely, then we're going to get some really skewed, messed up coefficients there. The logic of the issue isn't all that obvious, but if you think about it, if the two variables are perfectly correlated, then when you hold one constant, the other has to be constant as well. And so you're not going to get a disturbance term because there's no error around that, because it's always the same, right? If one is this value, the other one is, is constantly that value. So there's no error, there's no variation around that error term. So you can see what some of the problems are that might come out of that. What can be done about extreme multicollinearity? Well, multicollinearity has nothing to do with the dependent variable. Okay, so it's not about your y, it's not about your dependent variable. It's a characteristic of the relationships among your independent variables. So it's not affecting your dependent variable. It's only affecting those coefficients for the independent variables. So it affects the coefficient estimates for the variables that are collinear. It also doesn't have anything to do with any of the other independent variables. So if you have 4 or 5 variables in your model and 2 of them are collinear, those other independent variables are not going to be affected in terms of their coefficients, just the ones that are collinear. So it only affects the coefficients for the collinear variables. Other variables in the equation are not affected. In cases where the computer automatically removes one from the model, the one left represents, you can think of it as representing the combined effect of both the included and the excluded variable. But the problem is you can't determine how much comes from each of those. So you don't know how much of that coefficient is connected to the one that got included and how much of that coefficient is connected to the one that was excluded. Near extreme multicollinearity simply means that there are strong but not perfect linear relationships among the independent variables. And this is actually more problematic because it won't be picked up by your software program in the way that perfectly collinear variables will. And Allison points out that this is far more problematic because it can lead us to make incorrect conclusions without being aware of the problem. So you're going to get coefficients, they're both going to be in the model, but you can't trust the coefficients, but you don't know that you can't trust it. So that's going to lead us to make incorrect conclusions. So near extreme multicollinearity makes it more difficult for us to reliably estimate the coefficients of the variables that are collinear.